Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome back to another explainer. I am absolutely thrilled to get into today's topic because it honestly feels a bit like a detective story. We are unlocking the black box to reveal some truly fascinating software testing secrets. We're going to look at how testers evaluate complex systems from the outside in, basically playing the role of an investigator trying to crack a case when they have absolutely zero visibility into the actual mechanics of the code. Okay, let's dive right in. Picture this. You're dealing with a locked room scenario. You're standing in front of this massive, incredibly complex machine. You know it's supposed to perform specific tasks, right? But the door's dead-bolted, the windows are painted black, and the internal mechanics are completely invisible to you. So how do you test a system like that? How do you prove that it actually works? Or more importantly, figure out exactly how it breaks, when you can only deduce what's happening based on what goes into the room and what comes out? Well, that is the core mystery we are solving today.
To crack this case, here's our game plan for today's explainer. First, decoding the black box. Then, Technique 1, error guessing. Followed by Technique 2, cause effect. And finally, the user perspective.
Starting right off with Section 1, decoding the black box.
So, what exactly are we dealing with here? Well, black box testing is exactly what it sounds like. It involves testing a system where the code and all those internal pathways are completely invisible. The term black box literally refers to a system where the inner workings are just totally unknown to the person interacting with it. As a tester here, you're a detective who has absolutely zero knowledge of the internal code. Your testing focuses solely on the output that gets generated by a specific given input. You can't see the gears turning, you can only see what the machine spits out.
It all boils down to a super simple dynamic: input versus output. On one side, you have the input, literally just what we feed into the system. That could be a typed password, a tapped button, maybe an uploaded file. And on the flip side, we have the output, the generated result. Did it log you in? Did it crash? Did it throw an error message? We are operating strictly from the outside, watching this dichotomy. We basically just poke the box, and we meticulously document exactly how the box reacts.
All right, let's look at our first investigative tool, Section 2, Technique 1, error guessing.
Now, I love this technique because of how much it relies on psychology and intuition. Error guessing involves intentionally testing for the common mistakes that developers frequently make when they're building similar systems. Because we have zero knowledge of the internal code, we're basically using our gut to predict exactly where the original builders might have slipped up. It's a lot like profiling a suspect. If you know how software developers tend to think and where they tend to cut corners, well, you know exactly where to apply pressure to make the system crack.
So, who are the usual suspects in this lineup? Testers actually have a mental checklist of common mistakes they look for. First up, null values. What happens if you just leave a required form completely blank and hit submit? Next, what if you put text into a numeric field? Say the system asks for your age and you literally type out the word 20 instead of using digits. Or conversely, throwing numbers into a text-only field. And finally, testers will rapidly fire off inputs designed to expose known software vulnerabilities. We intentionally feed it incorrect formats just to see if this invisible system knows how to handle our bad behavior, or if it just completely breaks down.
But here is where it gets absolutely crucial. We have to talk about the sanitization of inputs, basically checking whether executably code can be submitted. Think about why this matters for a second. If a system doesn't clean or sanitize the input we feed it, a malicious user could literally just type a destructive command into a simple search bar. If that black box processes that input as actual code, the whole system could be compromised. So that single error guessing check holds massive security significance.
Okay, moving right along to Section 3, Technique 2, cause effect. While error guessing was all about playing hunches, the cause effect technique is a highly analytical step-by-step procedure. Step 1 is identification. We establish really clear relationships between influencing factors, which we call the causes, and the actual results, which are the effects. Once we've nailed down those relationships, Step 2 is to formally represent them using logical frameworks like Boolean graphs or decision tables. We are mapping out exactly how one specific cause triggers one specific measurable effect, making sure absolutely no logical pathway is left untested.
Let's ground this with a super relatable example. Think about testing a mobile app. On the left side of your table, you list your causes, influencing factors like a low battery state or no internet connection. Then on the right side, you've got your effects, the resulting outputs like an app crash or an error message. By mapping this out, the tester can systematically cut the device's internet and just observe the black box. Does it gracefully show a helpful error message like it's supposed to, or does it completely crash? This highly structured methodology ensures that common real-world situations predictably lead to safe behavior, rather than sudden catastrophic failures.
Which brings our investigation to its final stop. Section 4, the user perspective.
What you should really take away from all this is just how versatile and critical this approach is. Black box testing can be applied at absolutely every level of software development, from the smallest unit testing up through integration, all the way to final acceptance and rigorous security testing. And the absolute biggest advantage of all this, whether we're going with our gut to error guess or logically mapping out cause and effect, is that it focuses entirely on functionality and usability. It evaluates the software exactly as the user will actually experience it, completely unburdened by how messy or how elegant the hidden code might be.
So I'll leave you with this final thought. Think like a detective looking at your own digital life, or the systems you rely on every single day. If your system's code was completely invisible, locked inside a black box, what vulnerabilities would your inputs reveal? Would it stand up to the test, or would the box crack wide open under pressure? Thank you so much for joining me on this explainer. Keep learning, keep investigating, and I will catch you next time.